So 4.3 is going to be done in two parts. Today we're going to be doing multiplying, and then tomorrow we'll be doing dividing rational expressions. So when we're multiplying rational expressions, we know a rational expression is basically just a fraction, right? The big difference is that it has a variable in it. So just like when we're multiplying fractions, we know, for example, a over b, right, whether it's a number or variables or whatever, multiplied by c over d. We know that when we multiply these, we just get a times c in the numerator, b times d in the denominator. So multiplying fractions is sweet because all we're doing is we're going straight across, multiplying our a and c as well as our b and our d. Of course, when we're working with rational expressions, though, we know that we have to look at our NPVs. So in this case, b and d cannot equal 0. Okay? Division works a little bit differently, but I'll be discussing that tomorrow. Okay, so when we're multiplying, there's a couple things we always want to do. Always, 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 we have to make sure everything is factored. Okay? That's always our first step. The next thing we always have to make sure we look for is our NPV. I don't want anything canceled out until those NPVs are found. Okay? Our third step is kind of something that we can do in a couple different ways. Okay, so I'm going to put simplify and factor, or sorry, simplify and multiply. Simplify and multiply. Okay. This third step, the simplifying and multiplying, is pretty nice because we can actually do it in either order. We can decide to multiply and then simplify, simplify completely and then multiply, or do a combination where maybe I'll do a little bit of simplification and then a little bit of, and then the multiplication and then finish simplifying. Okay? So let's do our first example. So if I look at my first example, okay, so we'll go 4x squared over 3xy, and that's going to be multiplied by y squared over 8x. Okay? There's basically two ways we can do this. Like we said, our first step is always to factor, which we can't really do right now because we're looking at just monomials, but we do know our NPVs, right? So NPV, we look in the denominator and we say, okay, we have some x's, so x cannot equal 0. And then if I look, I also have a second variable, a y, so that has to be included as well. So y cannot equal 0. Okay, for solving this, kind of two ways we can think about this. So I'm going to show both ways. So we'll go like this. Okay, so the first way is if we simplify and then multiply. Okay, so if I was going to simplify and then multiply, I'm going to look at my original equation and I'm going to think about simplifying. So I might say, okay, well, I have a 4 on the top and an 8 on the bottom, so that can simplify to 1 and 2. I have an x squared as well as an x and an x, so this can cross out. And then, oh yeah, there's two x's, so my two x's from my x squared and my two x's in both denominators work. And then I have a 3, but nothing really goes with the 3 here. Oh, and then I have a y squared and a y, so I'm going to go like that. Okay? So when I look at this now, I say, okay, now on this side I have 1 over 3 multiplied by y over 2, and so I get y over 6 as my answer. Okay? So you can see how I simplified everything first. The other way of doing this is exactly the opposite. So instead of simplifying everything first, I'm just going to go straight across and multiply it. So we had 4x squared over 3xy multiplied by y and 8x. Okay, so if I just multiply straight across the top and straight across the denominator, just like that, numerators, denominators, okay, then I can say, okay, 4x squared multiplied by y just gives me 4x squared. Oh, sorry, that should be a y squared. Y squared. Straight across the bottom, make that y y look like that. I have 3 times 8 gives me 24. And then x times x gives me x squared and y. Okay, so I've done my multiplying, so now I'm going to simplify. So now when I look at it, I say, okay, well, 4 and 24 can both be divided by 4, so that leaves me with 1 and 6. X squareds can be divided by each other, and then my y squared and my y leaves me with just 1 y in the numerator. Okay, and then I look and I say, okay, that leaves me with a 1 y on the top and a 6 on the bottom. Okay, so either way is a perfectly valid way to do this, and it's really just up to personal preference. Okay, but we should get y over 6 with our NPVs, x and y cannot equal 0. Okay, let's look at a slightly tougher example. Okay, so if we have something like, say, for example, let's look at, let's go 12x cubed over 3x squared plus 6x. Okay, and that's going to be multiplied by 4x cubed plus 8x squared all over 5. Okay, so we know our first thing is always to factor. So let's do that first. Okay, so in the numerator of our first expression, 12x cubed, we can't really factor that. Okay, so that'll stay the same. But in the denominator, we can factor a 3x as our GCF. So 3x leaves us with x plus 2. Okay, and our second expression, our numerator can definitely be factored. So we look at this and we say, okay, our GCF is 4x squared, leaving us with x plus 2. And then we just have 5 on the bottom. Okay? So when you see something like this, once you see this and this match up, that should be like, we should get pretty pumped about that. Give yourself a high five when you see that, because you know your life is going to be getting a little bit easier. But before we can even think about canceling these out, we have to look at our NPV, right? So NPVs. So in our denominators, we have 2 x's, right? We have this one and this one. Okay, so our first one, the 3x, that just gives us x cannot equal 0. And then for our other one, x plus 2, we know, okay, x plus 2 cannot equal 0, so x cannot equal negative 2, right? So we can talk, or we talked in class about how we can also write it like this, right, as one line. Okay, so that's part of our answer right there. X cannot equal 0 or negative 2. Okay, let's get into doing some maybe cancellation. Okay, so right away, if you see 2 binomials that match perfectly, I want those out of there. So x plus 2 and x plus 2 are gone. Okay, lots of people when they get to this point might say, oh, I don't really know if I want to keep going with my simplifying. Like, things might get a little bit tough. Okay, so in the last example here, we showed how to completely simplify, right, here, and then do the multiplication. But you also have the option of simplifying partially. So, for example, in this one, what we've done is we've canceled our binomials out, but we are also welcome to go ahead and start to multiply, even if we're not sure if we're done simplifying. Okay, so we can go 12x cubed multiplied by 4x squared. So 12 times 4 gives me 48. And then x cubed times x squared gives me x to the power of 5. And then I have 3x times 5, so that gives me 15x. Okay, so that's one of the nice things. When we talk about BEDMAS, we know that multiplication and division are interchangeable. We can do them in either order. And so the true is same for this. When we're multiplying across, that's our multiplication step. But when we're simplifying, what we're actually doing is dividing it, right? So we have the option of going and doing the multiplying first, the division first, or a little bit of multiplying and then a little bit of dividing. Okay, so there's a lot of freedom with these questions. So now that we're completely done our multiplying, though, we do have to finish simplifying if we want to get full marks. So if I look at something like this, I'm going to say, okay, 48 over 15, those can both be divided by 3. Divide by 3. Okay, and then if I look at x to the power of 5 over x, I know, okay, if I want to divide by 1x, that'll leave me with x to the power of 4. So for my final answer, I should have 48 divided by 3 is 16 times x to the power of 4, and then 15 divided by 3 gives me 5. Okay, so 16 times x to the power of 4 divided by 5 with non-permissibles, because we know we can't forget those, of x cannot equal 0 or negative 2. Okay, so next time we'll be talking about dividing, but this is a nice little recap of the multiplying.